I'm Emil. I'm from Lookout, and I'm going to talk to you about mobile malware. But I have a suspicion that many of you don't actually know what Lookout is, so let me just tell you about that. So we're a mobile app, and we're trying to keep your phone safe. And we have a bunch of features, finding your phone if it gets lost, backing up your data, and the thing that I'm going to focus on tonight, which is protection from malware threats. So what the security team does at Lookout, and I'm on that security team as an engineer, is a number of different steps. So you can think of the way that we deal with malware and trying to find malware in the world is that we go through acquisition. We try and get as many apps in the world as we can. And then we run through some automated analysis where we try and figure out which of the things out in the world are interesting for our human analysts, our manual analysis to look at. And then once we have taken a look at those apps, then we can decide, oh, this is actually a good app. It just may use some more dangerous features of Android, or actually it's a bad app that does something bad that might hurt the user of the phone. And we'll talk about what bad means in a few different cases during the presentation. So specifically, what does mobile malware do? Well, malware authors are after a few different aims, and these are just a few of them, but they're the biggies. They're money, they're your data, like your personal data and contacts, and possibly access to your network. You can imagine a lot of phones, especially at work, at in corporate settings, have access to their own corporate network, to the internal infrastructure of their corporation or other enterprise, or possibly even government. So access to all of these things is really what malware authors are after. But we're kind of, we try and teach a message that we're not really into fear preaching. There's a really big danger with anti-malware vendors that everything sounds like, everything's really scary. But what we're really after is just having our users have a safer mobile experience in various different ways. So just as an example, we put out a mobile threat report earlier in fall of last year. And one of the things that we talked about is knowing what your risk is of being affected by mobile malware. And if you take a look at this is a heat map of the world with infection rates for mobile malware in June. And you can see that in the Western Hemisphere, things are sort of light green. And if you can see this, it's actually less than 0.2% for the very lightest green, and between 0.2 and 0.4% for the next shade up. Yes, sir?
Could you clarify what the statistic means? Is it infection rate among new Lookout users only?
Yeah, so you can take a look at the report. So the question was, what specifically is this number referring to, and is it about new Lookout users? And yes, it is about new Lookout users. The report actually explains why we chose that as our metric. It's a little bit complicated, so I want to get to the code tonight, but that's available on our website, and I'd encourage you all to take a look at that. Yes, sir. The question is, does the version of Android make any significant difference? I don't know. Yeah. Okay. So there's various ways that you can reduce your risk. And one of the biggest ways is just use official markets. It's actually not always easy for people in different parts of the world to do this, but here in the US, Google is here. Google has their official market. They do a pretty good job of keeping malware off of that market. So using Google Play is a really good idea. Avoiding apps from weird places. We've seen at least one incident of drive-by delivery of malware. So if you suddenly see that an application is downloaded after you visited a website, even if it's a seemingly legitimate website, probably you shouldn't install that application. And yeah, get a security app. I have my own recommendations, but I'll let you pick. Yeah, so there will be code now that we're done with that introduction. But before we can jump into the code, I need to talk a little bit about how we analyze applications and how we figure out what they're doing, and that'll give you context for what you're about to see in the cases of specific pieces of malware. So this is sort of a fairly common view of the Android development cycle. When you're creating an app, you get all this junk together, code and XML and whatever, and then throw it through the mystery box in Eclipse, and then an app comes out, right? More specifically, what's happening to that Java code is you're going through Java-C and DX to produce your classes .dex file. And so it looks a little bit like this, but what we're really interested in is getting back from the class's dex to the code. A lot of times when we discover applications, malware applications, source code is not included. So there are a few open source applications that you can use to get from your class's dex back to code. And one is Smalley. So Smalley is an assembler language for Dalvik, and Smalley is a decompiler from a dex file back into this assembly language. As far as assembly languages go, Smalley is like super easy and really, I think, quite easy to read. If you have any experience in assembler languages that address real hardware, this will be quite simple in comparison. And then the other option is to use a utility called dex2jar. So what this does is it converts from Dalvik bytecode back into Java bytecode. And Java by now is a very mature platform and has a lot of decompilers for it. They're of varying quality, and we'll see those variances tonight. But what dex2jar does is take you from the Android world into the traditional Java world and give you access to all of those decompilers and let you kind of see a semblance of what the Java code might have looked like. You'll see that there are, for various compilation reasons and decompilation reasons, there are some idioms that look very different when expressed in dex versus expressed in Java bytecode, and so those will come out as very bizarre Java code. So, given all that, that's what we're going to look at, is that bizarre Java code. It's still a little bit easier than the assembler. And we're going to talk about the money motive. So let me talk first about how premium SMS works. As premium SMS is really the sort of route that gives a lot of malware authors the ability to collect money from you without having to break into your bank account or anything like that. And so this is a picture of how the world is supposed to work, right? So I'm going to just zoom in here. And premium SMS, if you're not familiar with the concept, when I first came in contact with it, it was via various natural disasters a few years ago. You saw maybe like the Red Cross and other charitable organizations using this. They would say, text, donate to such and such a short code. And then that would be added to your phone bill, and you would have given a donation. But it's really just a generic payment system for various kinds of goods, and one that's sort of not quite as charitable is ringtones. So say you're really hip to get a new tune on your phone, and you want to get that. You find a shortcode provider, you text them a number, and say this is the shortcode that I want. The wireless provider gets it, sends the order to the provider of the ringtone, the ringtone provider sends you a message then, to confirm that you actually ordered that and want to get it. So it's a sort of double opt-in. You have to both request the content, and then you have to confirm that you actually requested it, so that there's no ambiguity, or hopefully very little ambiguity that you actually did intend to order it. Then you as a user confirm that. You're super happy. You have music in your heart, as it shows here. Then a few weeks down the line, you get your bill. You see that you ordered that ringtone, and everybody's happy. You have ringtone, they have money. Good, right? So this is how things work in the US. We have this double opt-in kind of thing. And there's also like a sort of a bad scenario in other countries with fewer restrictions around this. So one way that you might get charged for some stuff via this payment method that you didn't really want to get is you download a malicious application, and that then just uses your phone and sends a text message to a short code that you didn't know about. And then this is sent through all the back channels. They actually do the processing. You get your charge. What may happen is there's actually usually a receipt in just about every place that there is. It may not require an opt-in, but if you've worked with the SMS stack in Android, you know that you can intercept SMS messages and use them for whatever, like control channel stuff, or just present them in a different way if you're like a really nicely formatted SMS app. Or you can, if you're malware, just take receipts and throw them away so that nobody sees them again. So that's one possibility there. And then you get your bill, but you've been charged already, and the ability for you to contest this with your provider is limited in certain parts of the world with certain providers. So with that kind of background, let's talk about FakePlayer. This is one of the first pieces of malware that came out on Android, and it's a Trojan media player. What it does is it suggests to you that it will play you a certain type of media content for when you download it. It really only has one permission. So if you are looking at sort of as a user looking at apps, a lot of people get worried when there's a whole lot of permissions. But in this case, it only had just the one permission, which is send SMS. And that's really all it does. You do not get the content that was promised when it's installed. So what this is code of the main activity, and it's that decompiled code that I mentioned before. And what I'm going to do is zoom in on this a little bit. So I know hopefully very many of you are Android developers, so you'll see this is an activity. It's got an onCreate method. And then if you don't read Russian, and I don't, and Google Translate says that this says, hold on a bit, we're going to request some access to the video library. But then you actually see, what's this? A bunch of text messages sent directly to premium SMS messages. It's really very straightforward. Requesting access, send a bunch of text messages. This is really, one of the simplest, most straightforward pieces, and is one of the earliest ones. Yeah, I think you get the gist of that. But
Did that app only launch once, though? I mean, did it do anything? How did it actually get launched?
oh well, it shows up as like sorry. Oh right. So he asked how would the app get launched? The app actually purports in many cases to be a pornography app. So that was a type of media I was sort of alluding to. There are certain inclinations that might lead you to open that. So yeah, that's how they'd get you to open it. Yes, sir?
So it sounds like the key thing for a person to be looking for is the permission sends at SMS. How many apps, what percentage of apps want that permission?
So the question was that how many apps want the SMS permission, and is that really critical to look for? It is a really important high-risk permission to look for. I don't know off the top of my head how many apps request that, but it is used by a number of apps, and in a lot of cases it's not used necessarily by the app directly. It is used for a lot of legitimate payment SDKs, so you may get an in-app billing SDK for like games or whatever, for any kind of content that you want in the application itself. It may, as an SDK, require you to ask for the send SMS permission, and that uses that to charge you for the content. So there are very, very many applications that use send SMS for all sorts of stuff. I mean, it's really just used as a communication channel that also happens to do billing and texting. Right? So it's not, if you see an app that isn't just an SMS app or like a text app, and it still requests that, it doesn't necessarily mean anything bad that it's requesting that permission. Okay. So I'm going to move on to something in the same vein, but a little bit more sophisticated, and it's called Alpha SMS. And what it does is it basically charges you to download apps that are already free, and it has a couple of interesting features. It has really kind of a couple of custom encryption schemes, and it shows progressive improvements over time. We see these guys really producing a lot of new and more sophisticated versions of malware in this family. So it started off really simple, right? So this is just a utility function in the application, and really it's a wrapper that's very common in just about any application that uses SMS. The default parameters for send text message, a lot of times you don't need to fill all of those in. So they're doing what a lot of people do, which is just take, I believe this is either the content or the destination number and vice versa. So they just want to send this content to this destination number, and there's some other parameters and they don't care, right? So they're just making it a little bit simpler for themselves. So we went from this to this, right? This is basically the same function. It has the same capabilities. And let me just show you a few of the highlights of this beauty. So first thing you might notice is there's a bunch of string builders grabbing the value of a number, appending that to another number, converting it to a string, and then actually it's not even being stored anywhere. So they're just really, and it's sort of random what the numbers are that are in there. So these are actually basically just no-ops, but they're randomized no-ops. So there's all sorts of sort of background noise that they add to this application. And then up here, you see they're creating an array of class, and they're doing class for name, getting these classes, and then calling this method after with some randomized string, right? Well, what this is actually doing is this after is a custom string encryption method, and what it does, or it actually is a decryption method. So they've encrypted these strings, then they've decrypted them back, and they're getting a string and getting the class for that name. So you might recognize from the previous slide, or if you're familiar with the text message, send text message call, these three are the same, and the next two are the same. The first three are string, and the last two, I forget what they are. But these are actually the parameter types for the send text message method. And then if you're familiar with Java reflection, it's actually getting that method in string 1, which is not shown on here, they've stored and have decrypted send text message, putting that into a local method, and then going down through here, doing a few other things, and then eventually invoking that. So as I said, you can see this is how they're assigning the parameters again. It's pretty much the exact same method that we just saw in the previous slide, but a lot more complicated way of getting there, just to try and make sure that people like us don't find it. Okay. So they also have, you saw one sort of custom encryption scheme there. They also have another custom encryption scheme, and what this is it's a decryptor for an XML file that they've stored in the application. And I was just talking to Sasha before the talk, and he was saying he teaches a class on Android security and talk about encryption and stuff like that. Well, you've probably heard this before, but don't do your own encryption scheme. It's really hard to do encryption, and this actually is not that hard to break. So what's actually decrypted out of here is some SMS numbers to send premium text messages to, and also there's a little bit of scheduling in there, figuring out how often am I going to send those messages, how many times a day am I going to send those messages, all that stuff. Yes, sir. Okay, sorry. He just asked me to speak up a little bit. Should I repeat anything? Okay, sorry. Cool. So let's talk a little bit about data. This is actually really pretty straightforward, but you can see how, yeah?
On the SMS, you said that it wasn't such a big risk in our country because of rules or something along those lines.
Yeah. Oh, what's the question?
What rules can stop this from happening?
Oh, it's the double opt-in. So you'll need to, the question was, what kind of rules can stop the SMS attacks that we've seen? You need to, if you're an attacker, you need to send an SMS to the number. You need to then get the receipt back and reply to it with a response that says that you accept the charges. That can be of, whatever level of difficulty the provider puts in there. And then you'll get another receipt back. You'll also get a charge on your bill, which you can contest quite easily in the US if you notice that it's on there. So there are a number of rules that allow for recourse here, which are not as common elsewhere in the world. Yes? Uh-huh. Yeah, okay. Yeah, so he just said a few years ago he had access to a server where he could send you a text message and charge you $3 for that. So it's hard to do anything about that on device. Cool. So yeah, I'm going to move on then to the data section. This is actually just really straightforward. There's this family of malware called SND apps. And there's really, this is, there's not a whole lot to say about how you steal data, but if you look at what happens here, you see a function which takes in a few parameters, and it has a URL, and then it just takes a bunch of personally identifying data. And much to the chagrin of REST devotees, it sends all your data as a GET, but whatever.
Is this from the same malware or from?
This is from a different family of malware. Yeah, and a lot of this stuff too. So these are like, a lot of people stumble into this stuff unwittingly, and just decide, well, what I really need to do to keep track of my users is index them by email address, even if they haven't given me that, or index them by phone number, even if they haven't given me that willingly. And we don't consider that a reasonable thing to do. Okay, so I'm not sure what the intent of the one that I saw, or the one that I showed you just now is, but the various different things that you can do with this data, as you can imagine, is sell it to spammers, use it for marketing, or just being sort of thoughtless in the way that you, or lazy in the way that you index your users and deal with sort of regular app data. So I want to talk a little bit about what was actually a very well-constructed piece of malware called Not Compatible. And the function of it and the code of it are kind of interesting, but they're pretty sort of straightforward to describe. What's really interesting is what's done with this, how this was delivered, and how it's used to attack different parts of your network. So it was a drive-by download, and there were some websites, right, that, yes?
Sorry, can I just follow up on the data stealing? So you're not really suggesting that they're doing identity theft?
No, I'm not. So he asked, am I suggesting that they're doing identity theft? And no, they may not be. You know, you've got information about just your app usage sometimes, how people are interacting with your app, what activities they take within the application, and how to monetize that better. You know, just sort of very standard stuff that I think a lot of applications do. You can collect that in a variety of different ways. If your users say, I want to sign up for an account, and here's my information, and you have the rights via this terms of service that I agree to take that data and do what you want with it, then so be it, right? Somebody's consented to that. If they take all of that stuff and they don't say any of that, sometimes it's done without you consenting, or without you even really noticing that maybe there is no account to sign up for, then that starts to get into much shadier territory. Okay, so yeah, so not compatible. So there were some websites, totally innocent websites. I think there was a pesticide deal. Yeah, okay, thanks. Yeah, so there was some totally innocent websites. Pesticide, I think, are a pest control company in Florida and various other places that had no, you know, that are not malware distributors intentionally at all, got their websites infected. And then all of a sudden, they were getting a redirect so that when you visited their site with a mobile browser, you were being redirected in the background to download an APK, which is an Android application that was called Security Update. And if you clicked on that notification that you had downloaded something, it said, do you want to install the security update? So that was something fairly new. And then what it would do is basically just use your phone as a network proxy. So this is a little bit of the code. I'm not going to go too far into this like the other ones, but basically it's really just kind of a bot. You send requests of things to do on the network, and you pass that traffic through and pass it back, and it's just a straightforward proxy. Some of the things that were being done with this were you know, just buying tickets off of Ticketmaster and doing some searches on Google. So I'm not really sure what the intent was specifically, but you know, you can imagine this is very dangerous to let somebody have access to your phone and redirect traffic through it. So A lot of the things I've talked about so far were all things that behave within the permission model of Android, and they've, as we talked about before, you know, the app says, I'm actually going to use SMS here. Do you allow me to do that? And you say yes, and then it goes and does something bad. But there are some other ways, mostly historical at this point, that you can actually get access to the phone to root it, to do things that are not even allowed in your permission model. There's also a lot of people who have rooted their own phones for totally legitimate reasons, and there are some applications that try and take advantage of the fact that you have already rooted it and then, again, break out of the permission model. You know, with root, you root, you know. So there was actually a pretty cool, like really interestingly constructed piece of malware called Gamex earlier last year. And what it does is it downloads and installs apps, and then it runs them while your screen is off. And a lot of the apps that it downloads are totally legitimate applications that's just running. You can imagine, you know, we can only speculate why they were running these apps, even if they're totally legitimate, but you can imagine ad revenue or, you know, boosting your numbers of users, all that kind of stuff. And then just as a technique that it used, this really interesting zip payload technique, which I'll describe. So what you can see here is really just some of the code that is supposed to grab your existing root permission. So you can execute binaries in ELF binaries in Android. You just grab a runtime and call exec, right? So you want to run SU, go for it. If it's there, then you can run it. Then you can do a bunch of things, like you can, what this guy's doing, I'll zoom out here. You can remount the system partition and then install your application as a system app. Yes?
Isn't this making rather special assumptions about how the phone was rooted?
Yeah, so this was a question, isn't this making assumptions about how the phone was rooted? It is, but this holds true quite a lot of the time. So they just need high probability. They don't need perfection. The other thing that I should say about this is a lot of the really good sort of independent application or ROMs now, and SU applications, if somebody tries to do this, even in this method, you're asked in a UI screen, such and such an application is trying to grab root. Do you want to allow it to do so? And so that's a really great feature that you can help protect yourself. So if you don't know specifically what an app is doing with root, you can say no. Yes?
Just a general question. What is the difference between Trojan and malware?
So the question was, what's the difference between Trojan and malware? We would classify Trojan as being sort of a subclass of malware. Trojan is something that tells the user that it's going to do one thing, and then it does another.
Are you going to post this code for us for edification, not exploitation?
Right. So yeah, I think we'll have this available in one form or another. In fact, I think I'm doing a screencast right now, some way or another. Yeah. Question back there?
You were wondering why they would do something like this, but I mean, I get emails to my Google Play account offering hundreds of downloads guaranteed, and watchtower reviews and such, so they can sell that.
Right. So he just said that he gets a lot of spam as a developer, offering to get you a lot of installs and reviews for your application. I can only speculate as to why this particular malware author did what it is that they're doing, but that seems like a really good reason to me. Okay, so yeah, so let me just say here too, system apps have a really special place in Android too. You have to go out of your way to uninstall them. You have to be root to uninstall them. Fortunately, these in this case, you do have root, or else you wouldn't be able to install them. But you can't just go into the system settings, go to the apps page, and say uninstall. It'll say this is a system app and so forth. So, oops. Let me show you a thing that I think is cool. So this is a hex dump of a file that came bundled with this application. And as hex dumps go, it's pretty standard. It's a bunch of hex. But you might notice something weird, like right down here. There's a PK, and a PK at the beginning of a file is a zip header. So it looks pretty random. So you might just say, well, there's a PK in the middle of some random bytes. I don't know. But it turns out this actually is a zip file. And the way that I think it's libz is implemented, and at least on Android, and actually I think in Linux too. You can unzip this. It'll say like, oh, there's some crap at the beginning of your zip file, but it'll let you unzip it. And this is actually a zip file that has stuff in it. But you might notice, let me go back. You might notice this other thing up here, which is like, well, so is this file, it's got this PK down here, but there's also there's some real strings up here too. And there's like a BY up there. Well, it turns out if you look at the code of the application, what it does is it may unzip that zip file that we just saw, but then it'll take the same zip file, still zipped, XOR it, turn that BY into a PK, and then it's got another zip file. It's kind of cool. I don't know. It was a neat trick that they came up with, and then those strings turned into different strings, and there's different things in there, and there are various sort of helper applications that are actually installed by the malware. So, yeah. So I'm about to wrap up here, but if you're interested in this and how to do reversing and stuff, there's these tools that I mentioned. You probably also want to check out APK tool. I gave sort of an abbreviated mention to getting the other components that go into an application, but there's not just code. There's like those zip files and things that I talked about. So APK tool can help you get that kind of stuff out. Yes, sir. Yeah, so the question is about obfuscation, and yeah, so there are various ways in which obfuscation, especially at the DEX level, can be used to make these tools not work, and that's a topic of quite a bit of research in this area for these tools and attacks on these tools. I think actually one of our engineers gave some examples of ways to break these tools at the last Black Hat, and also some patches to fix them. So yeah, this is a battleground too. There are people trying to keep people from reversing their applications. Obfuscations in various different ways can be used to make these less effective. But as with all obfuscation, there can be put in an amount of effort to surmount that. The application still has to run, right? So the other bit that I want to mention, as Sasha graciously mentioned, I have the mobile security and privacy meetup. There's a few different things in this area. I think the guys at Passband have a mobile security meetup as well. Ours is the mobile security and privacy meetup. All good meetups to join and learn about. We talk a little bit about this kind of stuff at our meetup, tools and techniques for learning how to reverse Android applications. And if you're interested in learning more about that, or it's something that you think you might want to do, then you please come and talk to me. So thanks very much. Yeah, I have a question slide. Yeah, so the question was, recently there have been some Java exploits that have come out, I believe mostly in the plugin realm. To my knowledge, none of those have affected Android, but certainly, you know, the security model of any system is up for attack. So the question was, there are two ways to approach this problem. You can try and reinforce your security model at the operating system level and the API level and all those sorts of things, or you can have third-party approaches like the one that Lookout has. It actually turns out that in Android, there is a permission model that allows things like Lookout to exist. So in terms of efficacy, we think we do a good job. As I mentioned, it's very difficult to, you can allow certain actions, but understanding the intent of an application or an application developer is very difficult. And so I think it's really dangerous to go too far to the other extreme as well and just not allow people to do anything, because you could very well squelch you know, creativity and all those sorts of things. Yeah, so the question is there a way to detect the network activity of these kinds of applications which are using your phones as a proxy? And to some extent, there may be. There are a lot of these use their own protocols, which are, you know, if you know what a protocol looks like, you can start to detect it. Insofar as knowing specifically what traffic may come in and out of it, I think that'd be generally harder. You don't know if your phone is being used as a proxy for specific targeted kinds of activities, or if it's just being added to like a big Tor group, you know. So it's hard to say. So the question was, first question was about location tracking, I think. Have we seen any threats that use your location? And we have, and there's a range on the location. So there can be surely malicious apps that just want to track your location, but it tends to be more targeted. You know, if you get a random person's phone and start to track their location, it probably doesn't matter to you if you don't know who they are. But I'd say one of the things to be concerned about there is more stuff that's targeted specifically at you in a malicious way, and possibly even, you know, from somebody that you know. There are various applications that allow themselves to be hidden from the user, and that's something that we're not too fond of. And it's, you know, some of them are advertised as, you know, track your spouse, track, you know, whoever you want, and that, you know, that's very dangerous functionality. The other question was about other platforms, iOS and Windows Phone. I don't work in those areas, so I can't say specifically. I don't think there have been many threats for iOS, at least. Yeah, so we don't have data on that. The question was, is there any data about how users are affected by permission lists when installing? And I don't know of any research on that specifically, but I think it has been done in academic circles, but I don't remember specifically. The question was, can Google detect any of these exploits? A lot of these exploits are actually pretty old. The way that people root their phones now tends to be more tethered, but it used to be that there were vulnerabilities in various APIs or the operating system that were taken advantage of. Certain phones had certain specific vulnerabilities, and so a lot of these concerns have been patched upstream, so it's not as much of an issue. So the question was, are we building up a public database that anybody can search before they install an app? And our model is more that you install our app, and as you install the application, we scan it for you and let you know about if it has any threatening behavior.